Hi, I'm Stephen Augustiniak, and today I will be showing you my final for which is the interactive lesson plan. I am going to be doing mine on an astronomy lesson plan. I am going to be a science teacher for high school or middle school. I don't know yet, but since I'm doing it on astronomy, and I felt like this assignment would be very fit for an eighth grade classroom, so I decided I'd be doing this for eighth graders. So my lesson plan involves three different interactive parts. The first being a website that is very good for teaching kids about the night sky and different stars in the sky and constellations, and it gives them a good representation of what everything looks like at night when you might not be looking at it at night, or even if you're looking at it at night, it can help you find certain things that you wouldn't be able to, you wouldn't know the name of a certain star if you're looking up at the sky. So, and this website is called Stellarium. I used it for an astronomy class actually probably 2 years ago. And in my head, I picture eighth graders doing the exact same thing that I did, sitting in their backyard, looking at star and being like, oh, this star should be right here. You look up and you find a star in the night sky, and it corresponds to what you find on Stellarium, and it's actually really exciting. So that's what my whole lesson plan is circled around. So let me start off by talking about Stellarium and the first day that we would be going over this lesson plan, which they would use Stellarium and they would go over a quiz that makes sure they know how to use it. So Stellarium in general is it's pretty much the night sky, but on the computer. So you can look up at the sky, there's Arcturus right here, there's Vega, there's different stars, like all the stars you can look at. If you want to, you can get rid of you can get rid of, sorry about that. You can get rid of the landscape if you want, so you can look at the north and the southern hemisphere at the same time. You can add the atmosphere, you can get rid of it if you want, just to see the stars better. You can add the constellation art, but that's just more of a detail thing. But you can also add the constellations, so you can look at the different stars and what constellations they would actually be in. And this, for me, actually, in my class that I took, my astronomy class, was really exciting to me. And I feel like it would be the same for the students. And it's actually a really interactive and supplemental material that you can use in a science classroom. So what they would be doing on the first day and what I'd be helping them with is first downloading Stellarium. And then once I make sure everyone has Stellarium downloaded, I would run them through how to use it and how I showed you the constellations and everything and how to search different stars. Like I could type in Polaris, that's the North Star, and I could click on it and it'll show it right here. So I could show my students how to do that. That would be the first half of class on the first day. And then on the second half, in the second half of class, let me go back. I'd give them a quiz, and this quiz they could use Stellarium with. And it's just a quiz to make sure they know how to use it before they go home that whenever over the next week and look at the night sky and use Stellarium to figure out what they're going to do. So a few questions that I have on my quiz, like how far away is Arcturus? You could look up Arcturus, you could find it in the night sky on Stellarium, and it would give you this information. The right answer is 36.72 light years away, but you could look that up and it would show you that as probably like the second option. And then I have different questions like what is the real name of the Big and Little Dipper? And they could look for the shapes of the panhandles and the Big and Little Dipper, and they could find that they're called Ursa Major and Ursa Minor. So just to make sure that they know how to run Stellarium and actually go through it before they get to the next step, which over a week probably, I would give them a week to do this, is they are going to use Stellarium. They're going to pick a random, well, not random, they're probably going to pick a star that they see in the night sky of Stellarium, and they are going to do research on it. They're going to look it up. They're going to find how big it is, how far away it is, where it is compared to other stars. And they're going to use something called the hand method. And let me go down to that. So what I want to make sure students learn and take away from this is how astronomers first made measurements of stars in the sky. And one of the things is that they used the relative distance between stars. And one easy way to do this is to sort of estimate it, which a pinky, if you stick it up in the air and put it between two stars, would be 1 degree difference. If you use 3 fingers, it's 5 degrees, a fist is 10, and so on. To these different hand gestures, you can find different degrees between different stars. So what they would do with that is, I'll go up here to show my third, which is a Canva poster. I want them to make a poster online using the technology of Canva to pretty much show off their research that they did on their one star. And the things that I want to be on this poster would be like, what's the name of your star, of course, what constellation is your star in, if it is in a constellation, how big is your star, how old is your star, how far is it relatively from 4 other stars or planets, using that relative distance with the hand method. And just for fun, what's one cool fact about it? So to show my students what I would want from them is a poster down here. I made this on Canva. It's sort of a quick hand version of what I would want them to do. So I put the name of my, this is actually my favorite star. It's part of Scorpius. It's a bright red star that you can see in the sky if you find this constellation. Some of the information that I said for them to put on here is how big is it? It's 293.96 miles in diameter, a million miles in diameter. It is 11.01 million years old. And a fun fact, I don't have the relative distance between this star and other stars just because this is a quick version, but I would make sure they would have that on there. But a fun fact that would be acceptable would be Antares is actually 700 times larger than our sun, which is kind of crazy to think about. So that's the kind of poster I would want them to make for this last part of the lesson plan. And that the second day that this lesson plan would be going on is I'd want them to take that poster that they made with their group of 2 or 3 people and present it to the class, talk about it, give us their fun fact, and in the process, I would hope that with all the interactive different things that they went through to find this stuff about their star, they learned something about relative distance between stars and things like that. So to close off this lesson plan, I'd pretty much just have a discussion with all my students once they finished up their presentations. I'd ask a few questions similar to this, like why is the distance measured in degrees when it comes to relative distance compared to light years when you're looking at the actual distance from the Earth? Like, are the stars that were observed actually as close to, as the relative distance says? Of course, they're not, and I feel like that would be a thought-provoking question for them to think about and maybe give some good answers. And what else could be taken away from this that we did not talk about? And I feel like that question is partly for them to, it's sort of thought-provoking to help them interact and think of in different ways of what this could be used for, and to help me in the future to make this into a better lesson plan if I were to use it. So thank you for listening to my lesson plan. I hope you learned something, and I hope you have a good day.